Alright, we're going to set up and finish the last two sections of Chapter 2 today, which are 2.7 and 2.8. So 2.7 is assessing a regression model, and 2.8 is fitting the models to curved relationships. So on the screen right here, we'll set this up with just going through a few things, make sure we're all good. So a residual plot will be a scatter plot of the residuals against the explanatory variable. Residual plots help us assess whether a linear model is appropriate. Residuals equals actual minus predicted. Okay? So when you have residual being actual minus predicted, taking the actual value, so in which case if we took 5, but the predicted is what is predicted by the least squares regression line. So whatever in this case the purple line here, the equation for that, let's say it gives us the value right here on that line is 8. So we're simply saying to find the residual, in other words, the distance between, so the residual is the distance between least squares regression line and the point, the actual point. So our actual point in this case was 5. Our predicted was 8. Therefore, the residual should give us -3. And it's negative because that actual dot was below the least squares regression line. So therefore, that is why it's negative. As to where if we were to go this point up here above the line, if we were to do this point, then it would give us a positive residual. So least squares regression line was fitting the best line in between all those points to give the smallest residual values. So hopefully that makes a little bit of sense. I know it's a little recap on 2.5 and 2.6, but that's what we're talking about. So the residual plot is an actual plot to show those residuals a little bit easier. We're going to go over that, show you some of those. The next one you need to worry about is coefficient of determination, your r squared. So your r squared value right here, right? Coefficient of determination is a fraction of the variation in the values of the y that is accounted for by the least squares regression line of y on x. So the best residual plot has a random scatter and a high coefficient of determination and a small s value, which the s value is your standard deviation of the residuals. Good model right above that. Your good model is all the scatter points. And the bad model is if it has a shape, if it forms a V or a U. So we're going to look at this and say how many iPhones will be sold, okay? So there's some data here on the years in which iPhones came out and the units sold in millions. So first off, I want us to make a scatter plot using this data. Went to staplet.com, okay? And I went to staplet.com and I put all these data points in here for the explanatory and a response. In which case, that gave us this scatter plot right here. It gave us this residual plot down underneath. So there is our scatter plot, right? Describe the form of the distribution. So what do you say that form is? Do you feel it's linear or nonlinear? Hopefully you say it's nonlinear, because as you saw, we've got this curve of the data points going that way. Whoa, that was nasty. So anyway, it's going to be curved, right? So let's see here. Use the applet to find least squares regression line. So now we want the line, the equation for the line. In the applet here, it'll give us that equation, okay? So the equation for the least squares regression line, which is right here, so that is the equation we get. Now granted, you don't need to have all those zeros there on your slope. You could have left that at 1.605. Then it wanted us to do that. So that again, that's the least squares regression line equation, okay? So then it wants to go in there. We got our residual for that residual plot based off of the least squares regression line, okay? It gave us kind of a U-shape setup, right? It's kind of a shape to it. So it's kind of a shape going, right? It's not really just scattered. It's actually given an actual shape overall. However, then it wanted us to go back and do the residual plot using a quadratic regression. So instead of doing the linear least squares regression line, let's do quadratic. So you can go down here underneath this, calculate other regression, quadratic, calculate the regression model, and it will give you this setup, okay? In which case it gave us that. Let me show you again. So if we get up here and you click calculate the least squares regression line, it gave us that residual. If you click on calculate the quadratic, it changes it. And that's the scatter plot we got right here, which looks a lot better because they are scattered points. So there's scatter points all around on the residual plot. So in other words, too, when we were talking about the residuals earlier, then it just wanted us here to see what the coefficient of determination value was for both of these. Least squares regression line, it's right here as far as 0.914, and for the quadratic it's 0.984. Now again, this is for the least squared regression line, which is this first one we did right here. This one's for the quadratic, which is what we did right here. So least squares regression line, the reason why that's a bad fit is because if you were to try and draw just a vertical line, it wouldn't fit real well. Now mine looks like it kind of fits well because I've got a thick line going on there. But the actual quadratic, since a quadratic would have a curved aspect, makes it fit even better. And that line is horrible, I know, but it would make the curve look a lot better. So as you can see, the quadratic line fits it a lot better. Alright, and so with that, being that we've seen that, of course, it asks for, in order to choose the best regression model for number 7 right here, we look for the residual plot with the random scatter of points in the highest r squared value, or coefficient of determination value. So based on this, what is the best model? And if we look at that, we pretty much just said in multiple ways. Again, our quadratic has a higher coefficient of determination and has the best scatter. Okay, this is no good. However, the quadratic is better. So overall is the best model for that. R is our residual. Okay, r squared is our coefficient of determination. The S that we saw is our standard deviation of the residual. Now, standard deviation of the residuals, that tells us the typical amount of distance between the actual and predicted. So in other words, this residual, which equals actual minus predicted, the S is the amount, the typical amount of distance between actual and predicted. So those are the three things you need to take away from this. Now, one last thing before we go, just want to make sure that everybody's comfortable too with on dealing with the regression equations down here at the bottom down here, the regression equations, okay? Regression equations, in which case for the linear line, hopefully you all understand, it's a y hat equals your a plus your bx, okay? The quadratic, which we found fit our example very well, is your y hat equals a x squared plus bx plus c, of course, typical quadratic equation. And the exponential, typical exponential equation as well, but it's y hat equals your a times b to the x power. So as we saw with our equation, let me pull it back up real quick. Here's our equation for the quadratic. Again, you have your ax squared plus bx plus c, right? And the actual linear for the least squares regression line is your b or a plus bx. So that is what those equations are looking for. So if they ever give you just a residual plot and give that for their equation, you'll already know what type of plot they used for that, okay? Again, we have a good model for residual plot is the scattered. It's going to be a scattered plot. Bad model, of course, is going to form a shape. All right, guys, hope you got a good understanding of dealing with that with the regression models. I'll see you next time.